Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. In the last 10 years, an abstract mathematical concept has been applied to materials. Topology classifies geometric objects based on whether they can continuously deform to look like each other. Now, one research group has used this concept to develop a metamaterial that can tailor thermal emission. Rather than using a periodic system, which most topological materials employ, the team borrowed a concept from laser design and created an optical cavity using a dielectric medium sandwiched between two layers that act as mirrors, a metal substrate and a top layer of platinum.
Cavity means you have two mirrors and that you trap light between two mirrors. But our cavity is slightly different. We have a bottom mirror, which is perfectly reflecting surface, but the top mirror is partially reflecting mirror, but at the same time, it is thermal emitter. So basically, thermal emission is coming from the top mirror. At one resonance condition, we observe this topological phase transition. So this cavity goes through a topological phase transition when we change the thickness of the top layer. So the thickness of the top layer defines the topology.
That was Professor Koskun Kojabash from the University of Manchester in the UK. The thickness of the top layer controls the emissivity. At a critical thickness of 2.3 nanometers, perfect emission is achieved. Under these conditions, the physics at play is similar to the physics behind how a laser converts incoherent light to coherent light. One key aspect of the research is that the interface between two surfaces is required.
There is this topological argument. If you have two topologically different objects, and if you bring them together and if you form a boundary, what will happen at this boundary? Because you go from one topology to another topology, so you have to go through a boundary which should emit. So we look at the surface with an infrared camera and two cold surfaces, because they have low emissivity. At the boundary, we see very hot line. So that line, this boundary, is indicator of this topological phase transition.
The metamaterial, which is essentially a multi-layer coating, can be used for thermal regulation in environments where conventional cooling cannot be used. This applies to applications in space satellites where you can't simply blow air over an electrical component but need to absorb or reflect incoming radiation, military uses where you want to control a heat signature without causing overheating, or to infrared optics. This work was published in a recent issue of Science. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.